Okay, so in this problem, we are going to find the centroid, center of gravity, center of mass, whatever, on this volume over here. So the steps that we take to do this is we draw a thin disk, okay, like so. So you've got this this thin disk, okay, and then from that thin disk, we need to determine the dimensions of it. Okay, so in order to find the volume, I need both the radius and the thickness. The radius is essentially y. Okay, it's the value y. Okay, from the z-axis out to the edge, which is y, which is given by this equation. So solving this equation for y, and you get dy. I'm sorry, you get y equals square root of 2z to the 1/2. Okay, and then the thickness is going to be dz. It's infinitesimally thin in the z direction. Okay, so the volume is pi r squared times the thickness, the volume of a cylinder basically, or a disk. So pi, instead of r squared, we have y squared. Okay, dz. So that's pi r squared times the thickness, where y squared essentially equals 2z. Okay. Times dz. So I have basically 2 pi z dz. That's what dv equals. That's the volume of that differential element that I've drawn there. Okay. The other thing I need to know is the centroid location. And really it's just at some arbitrary distance z away. Okay. And we're going to integrate over, we're going to basically stack these thin disks one on top of another, okay, to create this object. Okay. So we're going to apply that equation. Okay, where it's the integral z tilde dv over the integral of dv. So I take what I know about dv and z tilde. Top equation is z times 2 pi z dz, which is the dv. And then the bottom is just 2 pi z dz, which is dv. Okay, my limits of integration are 0 to 2, and I'm going essentially from 0 up in the z direction, because again I have a dz here, so I go from 0 to 2. Okay, and this is my integral. And really at this point I just do the calculus to solve it. Okay, 2 pi gets pulled out, right? So I'm left with z squared dz here and z dz here. So I get z cubed over 3, and here I get z squared over 2. Limits again are from 0 to 2, so plugging those in I get a value of 4/3. So again, you draw the differential elements, write the dimensions of it, figure out what dv equals in terms of all the coordinates, and apply the centroid equation, the integral equation.